Section 7.3, Periodic Graphs and Amplitude. Our objectives are to state the period and amplitude of the trig functions and to be able to graph, and from a graph come up with an equation. Now, remember we talked about previously that a wave is the same as a cycle. It is a portion of the graph that shows a complete pattern. So one cycle equals one wave, which is also the period of a function. So the period of function is the length of one cycle, and remember it's the horizontal distance required for one cycle before your graph starts to repeat. Now it's helpful when we're doing this to always note what the parent graphs look like for sine and cosine. So remember sine starts at 0, cosine starts at 1. The period for our parent function is 2 pi, so our key points go by pi over 2. How do we get those key points? Remember that your sine and cosine has maximum, minimums, and intercepts, and so those key points are found when you divide your period into 4 equal parts. That's where pi over 2 comes in. Same thing for cosine. Now, for these, we're going to change up our equations. Before we had our d value on the outside, we did y equals a times the sine of x plus d, and that value is on the outside. So we talked about stretching vertically and compressing vertically, moving our graph up and down. Now we're going to talk about horizontal movements. So we're going to use that b value for our horizontal movements. So we have a sine of bt and a times the cosine of bt. So if b is greater than 0, then the graph of either sine or cosine, the new functions that we have here, makes b complete cycles between 0 and 2 pi. And each function has a period of 2 pi over b. So you always take the parent graph period, which for sine and cosine is 2 pi, and divide it by b, which is the number of cycles that you're making in between 0 and 2 pi. And if a is not equal to 0, has an amplitude of a. So remember that b value, when it is greater than 0, the absolute value, it's a horizontal compression. So that's what we have right here. So that means the graph is going to repeat itself more frequently than its parent graph. When b is in between 0 and 1, the absolute value, it's going to be a horizontal stretch. So the graph is going to repeat itself less frequently than the parent graph that we have. And just to show you what I mean for this, I'm going to go to my calculator so that you all can see what I'm talking about. So in my calculator, I have graphed the sine of x. And for the sine of x, I graphed it from 0 to 4 pi, as you see here. So one cycle, one wavelength for the parent graph would be right here. So this is y equals the sine of x. And so notice that we see 2 cycles up here. If I change that b value and maybe instead make it a 2, then if I draw one wavelength would be from here to here. So notice that if I make that b value 2, I would have y equals the sine of 2x. And when we're doing this, remember we said that this 2 makes this a horizontal compression by a factor of 1/2. So if you look at our graph, notice that it's half of the parent graph, sine of x, and notice that now it completes, here's one cycle. This would be the second cycle from 0 to 2 pi. So first cycle, this would be the second cycle from 0 to 2 pi. So that's why we said it completes b cycles from 0 to 2 pi. And so notice that my graph is going to be more frequent than our parent function graph. And so right now you notice that from 0 to 4 pi, I see 1, 2, and then we would have another one, 3, 4 of our waves. If I do 3 for my b value, notice that that would be a horizontal compression by a third. So now our graph would be 1/3 of our parent graph. And so it's going to complete 3 cycles between 0 and 2 pi. If I change that b value then to something in between 0 and 1, like maybe 0.5, so now my equation that I have is going to be y equals the sine of 1/2 x, and so this would be a horizontal stretch by 2. So when I do that, notice that our graph is going to be less frequent than our parent graph, and this is the wave that I get. And for this wave, notice that half of it is now part of our parent graph. So it has stretched out to 4 pi. Now for these, we have to come up with what the new period of our function is going to be. The way that you come up with what the period is going to be is you take your parent graph period, 2 pi, and divide it by your b value. So if we look at this graph that we just did, I have 2 pi, so my new period is going to be 2 pi divided by my b value. So 2 pi divided by 1 half would be 2 pi times 2 over 1, which is where we get the new period of 4 pi. If we think about the graph that we did in green, the new period, so new period of our graph, or the period of this function, I should say. It's not really new period. I'm just talking about new period from our parent graph, y equals the sine of x. So it would be 2 pi divided by our b value, which in this case, our b value is 2. So 2 pi divided by 2 is pi. And that makes sense because it was a horizontal compression by a half. Now for this, remember I talked before that we're going to have to be able to find our new key intervals because they've changed if we're stretching our graph horizontally or if we're horizontally compressing our graph. So how do you find these new key points on your graph? Well, remember if you have the period of your function, it's divided into 4 equal parts, which we've talked about before. So for my graph right here, y equals the sine of 2x, if I take that new period, to get my key points, I would take that and divide it by 4, multiply it by 1/4. So our new key intervals for this graph are going by pi over 4. So right here, this would be 1 pi over 4. This would be 2 pi over 4. This is going to be 3 pi over 4, and then 4 pi over 4 is pi. So notice now I have all those key points by counting by pi intervals of pi over 4 on my graph. So for this one that we have right here, if my period is 4 pi, then I take my key points are going to be 4 pi divided by 4. So my key points go by intervals of pi. So if we look at this, this would be my maximum. So we have our intercepts maximum. So 1 pi, 2 pi gives me 0. 3 pi gives me a -1, and 4 pi gives me 0. So those would be the new interval points that I have. So that's why I said it was really important to make sure that you can write down your key points because they help us find the maximum, minimum, and the intercepts of our graph, especially when we're doing horizontal movements. So going back to the notes, let's do these equations that we have down here. It says determine the period amplitude of each function. Okay, so I put this on a new page so that I have room to write. If we look at this graph, we want to determine the period and the amplitude. So remember, we have y equals a times the sine of bt, that what we're using, or y equals a times the cosine of bt. Now for these, the first one, we have 2 cosine 3t. For this, we know that the amplitude, A, is going to be equal to the absolute value of 2, which is just 2. If I want to figure out the period of my graph, well, my b value is equal to 3. Because my b value is equal to 3, I know that this is a horizontal compression by 1/3. So that means that this graph is going to complete 3 cycles between 0 and 2 pi and from our parent graph. So if I want to figure out what my new period is, remember you take your parent graph period, which is 2 pi, and divide it by your b value. So this would be 2 pi divided by 3. So my new period of my function is 2 pi over 3. Now, I didn't ask you to do this next part, but let's say we wanted to come up with our intervals for our key points. So to do that, your key points are going to go by intervals. You have 2 pi over 3, and remember, you divide it into 4 equal parts or multiply it by 1/4. And when I do that, I end up with pi over 6. And if you're counting on your graph, you just start at 0. So 0 would be the first place. Then you would have pi over 6, so 1 pi over 6. And then you would have 2 pi over 6. So 2 pi over 6 is pi over 3. And then you would have 3 pi over 6, which is pi over 2. And then 4 pi over 6 gives you 2 pi over 3. And so those would be the key intervals that you're going to be marking on your graph. And again, all I did was count 1 pi over 6, 2 pi over 6 reduces, 3 pi over 6, 4 pi over 6, again, all those reduce. And then I would draw my graph, which is what we're going to be doing next. So let's look at B here. For B, the amplitude of this graph is the absolute value of 1/4. So that's equal to 1/4. My B value in this case is we have T over 2, so 1/2 would be my B value. That means this is a horizontal stretch by a factor of 1 over 1/2, so by a factor of 2. This means that from 0 to 2 pi, we're doing a half of a cycle, which is what we showed before in the graph that I did on the calculator. So for this one, if I want to come up with my new period, the period is equal to your parent graph period divided by b, so 2 pi over b. So in this case, we have 2 pi divided by 2. And so 2 pi over 2 gives me, sorry, I divided by 1/2, not 2. 2 pi divided by 1/2, because that's our b value. So that gives me 2 pi times 2, which is 4 pi. So the new period of my function is 4 pi. So again, the key points for this are take your period, 4 pi, divide it into 4 equal parts, going by pi. So my key points would be 0, pi, 2 pi, 3 pi, and then 4 pi would give me one wavelength for the new equation that I have here. So I'm going to make this a little bit smaller, so I can write for the next equation. Okay, so this last equation that we have here, the amplitude is equal to the absolute value of -3, which is equal to 3. The b value is now pi over 3. So this pi over 3, I know it's going to be a horizontal compression. And the reason we know it's a horizontal compression is because pi divided by 3 is about 1.04. So since it's over 1, it's a horizontal compression by a factor of 1 over pi over 3. So by a factor of 3 over pi, I guess. And now we want to come up with the period for this graph. So the period, take your parent graph period, which is 2 pi, divided by your b value, which is pi over 3. So this is 2 pi times 3 over pi, because you multiply by the reciprocal when you're doing that out. And notice that your pi's in this case cancel out, and you're left with 2 times 3, which is 6. So not always for these graphs are you going to have pi for your key intervals. Sometimes your pi's are going to cancel out depending on what it is that you're using. So for this, my key intervals for my key points, so your key points then would be take your new period, which is 6, and divide it into 4 equal parts. So in this case, they're going by 3 halves each time. So in this case, I would start with 0, and then I would have 3 halves, and then I'm going to add another 3 halves. So 3 halves plus 3 halves would give me 6 halves, and 6 halves is really equal to 3. And then I would add another 3 halves, which would give me 9 halves. And then I would add another 3 halves, which would give me 12 halves, and 12 divided by 2 gives me 6. So those would be my key interval points that I'm going by to get my new maximums, my new minimums, and my new intercepts. So let's go back to our paper. So again, if b is greater than 0, then the graph of tangent A tangent BT makes B complete cycles between, and we're not using 0 to 2 pi now, remember, because tangent, the first cycle is in between -pi over 2 and pi over 2. And the function has a period of, instead of 2 pi over b, it's going to be pi over b. And remember that tangent A is not an amplitude, that it's just a vertical stretch or compression, because tangent goes to infinity and negative infinity, so we don't have an amplitude for it. If we look at the first example, determine the period of each function, let's look at that A value. So this A value is 2, so that's a vertical stretch by a factor of 2. And then our B value is equal to 2. Since the B value is equal to 2, I know this is a horizontal compression by 1/2. So from negative, so for this, we're going to have half of a cycle in between 1 for our parent function. So our new period we take to find it is equal to your parent graph period, which is pi, and divided by your b value, which in this case is 2. So the period for this new function would be pi over 2. If I wanted to do my key points, I take the new period, pi over 2, and divide it into 4 equal parts, so multiplying it by 1/4. And when I do that, I would get pi over 8. So my key points would go by intervals of pi over 8. If we look at B here, for B, there's no vertical stretch or compression because it's just 1 in front, so we don't have anything there. But my B value is 1/3, so that's going to be a horizontal stretch by a factor of 3. And then if I want to figure out the period of this new graph, I take my parent graph period, which is pi, and divide it by my B value, which is 1/3. So that gives me 3 pi. And if I want to figure out the new intervals by which my graph is going to be going for my asymptotes, because tangent doesn't have the max or minimums, it has asymptotes on our graph everywhere. Cosine is 0, remember? So the new points would be going by, for our key points, 3 pi divided by 4 equal parts, so 3 pi over 4. The next thing you need to be able to do is to write an equation given the graph. So here we have a graph, and remember, you always want to think about your general graph for sine and cosine. And if I look at this, usually I start off by looking to see what my maximum and minimum points are, to see if I have a vertical shift, and what my amplitude is. That's the easiest place to start. So I'm going to start with my maximum. My maximum in this case is 5. My minimum in this case is -5. So if I want to find my amplitude, I'm going to extend this a little bit. My amplitude is equal to, remember, the maximum minus the minimum divided by 2. So 5 plus -5 divided by 2 would be 0. So that I have sorry, I'm thinking of the minus. I did a plus. I didn't realize I just did that. So get my eraser. So this should be minus. I didn't put a plus there accidentally. Okay, so minus would be 10 over 2, which makes more sense because you're not going to have a 0 amplitude. That's why I knew I didn't do that right. So 10 divided by 2 would be equal to 5. So this is my amplitude. What I just did was actually your vertical shift. So remember that d value that we had. So if I write y equals a or times the cosine, and now we have that bx value plus d. Remember that d is your vertical shift up or down. So the d would be your maximum plus your minimum divided by 2, which is what I just did a minute ago. So 5 plus -5 over 2 gives me 0 over 2, which is 0. So that tells me my graph didn't shift at all. After you find if your graph shifted or not, then you're going to want to, that your axis is still the same. That helps me determine if this is going to be a sine or a cosine graph. So if I look at that shift, notice that your graph doesn't go through the middle for a sine graph starting here at 0, 0. Instead, it starts up. So that means this is going to be a cosine graph that I'm going to use. So if this is a cosine graph, that means I want to figure out what my period of the function is, because I'm going to have different wavelengths now that I'm changing them. So if I start here, I know the amplitude is 5. So one wavelength for cosine would start up, go down, and then stop right there. That would be one cosine wavelength. And I have to look. The period is going to be the horizontal distance that it takes to complete one wavelength. So if you look at your graph here, notice it stops from 0 to 4 pi over 3. So that means that the period of my graph is 4 pi over 3. Now, we don't use the period in our equation when we're writing it out. Remember, we use our b value. So that means now I have to figure out how to find how many cycles I'm making from 0 to 2 pi. So how do I figure out that b value? Remember, we had the period, new period was equal to the parent graph, 2 pi, divided by b. So I can use this equation to solve to find what our b value is going to be. And if I do that, I have 4 pi over 3 equals 2 pi over b. So I can solve this by cross multiplying. So I get 4 pi times b equals 6 pi. So b would be equal to 6 pi over 4 pi. And then, of course, your pi's cancel out. And then we know 6 over 4 is just 3 halves. So this is my b value. Another way to think about this equation right here, instead of cross multiplying all the time, well, if I just solve for b for this equation, I would get the period times b equals 2 pi. So your b value is always going to be 2 pi over your new period. So notice that the equation is the same pretty much. So whenever you're finding your b value, it's your 2 pi over your period, or whenever you're finding the period, if you're given an equation, you do 2 pi divided by the b value. So it's kind of works hand in hand. So now I have my b value. I didn't have a vertical shift. I'm not moving my graph left or right at all. That'll be the next section. And I know it's cosine. So notice that my graph starts up here at 1, so we don't have a reflection that we have to worry about. I just have to go ahead and write my equation. So my equation for this graph, I'm going to make this smaller. So the equation for my graph, I have everything I need. So y equals a times the cosine of bt plus our vertical shift if we have one. So these are the values that I'm putting in. So my a value is 5, so y equals 5. We already talked about why it's a cosine graph. My b value is 3 halves t, or you can use x, it doesn't matter. And then I don't have a vertical shift, so this would be my equation for this graph that we have up here. Let's go ahead and do the next graph. So for this next graph, I'm going to do the same thing. I use my maximum and my minimums to help me figure out if I have a vertical shift or anything, where my axis is going to be. So my maximum is 2. My minimum is equal to -2. So my amplitude is equal to, and I know it's going to be 2 just by looking at it, but your max minus your minimum divided by 2. So we get 2 minus -2 divided by 2, which gives us 4 over 2, so 2. And then my vertical shift would be, again, the maximum plus the minimum over 2. So 2 plus -2 over 2 gives me 0. So there's no vertical shift. So because of that, I can count from my maximum down 1, 2. I know that my axis hasn't changed, and notice that my graph starts here and goes through 0. So because it's going through 0 and up, down, that would be my first cycle. And I know it's going to be a sine graph. Do that in different color so you can see. So now I need to figure out what the new period of my function is, the horizontal distance from here to here where it completes one wave. So if I look, it's hard to see up here, but on your graph you can tell that that is 4 pi, because each one's going by pi for the intervals. So the period is equal to 4 pi. So if I want to find that b value, Remember, the b value is going to be 2 pi divided by your period. We talked about why that is. So in this case, we get 2 pi over 4 pi, which gives me 1/2. So 1/2 would be my b value. So if I write my equation now, I have y equals a times the sine of bt plus d. Notice your horizontal movements, usually you put them in parentheses. So in this case, my amplitude is 2. My graph starts here at 0 and goes up, so I didn't have a reflection. If it was going the other way, like let's say it went down first, like this, then you would have a reflection, and you would want to put that in front, but we didn't have one, so we don't have to worry about that. So you get y equals, in this case we have our amplitude, which is 2, times the sine of my b value, which is 1/2 t, or you could write t over 2, it doesn't matter, and then no vertical shift. And that would be the equation for my graph. So let's go ahead and graph one of these together, just so we can get used to graphing them. So by hand, we're going to graph y equals the cosine of 3t. We'll start off with something easy. So for this graph, their amplitude is the absolute value of 1, so the amplitude is 1. I have a horizontal compression by 1/3 because my b value is equal to 3. That tells me I need to find the new period of my equation. So the period is 2 pi over your b value, so 2 pi over 3. We've talked about this one before. So your key points are 2 pi over 3, divide it into 4 equal parts, or multiply it by 1/4, and you get pi over 6. And we talked about how to get that in the last equation. Now I have this, I can start doing my key points on my graph. So this would be 1 pi over 6. This is 2 pi over 6, or pi over 3. 3 pi over 6, which is pi over 2. And then, so 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6 is 2 pi over 3. Then we have 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6, and this is just stuff on your unit circle if you notice we're going around. And then 4 pi over 3, so we're going around on our unit circle since our intervals are pi over 6. 3 pi over 2, and then I have 5 pi over 3, 11 pi over 6, and then 2 pi. So I'm going to graph it from 0 to 2 pi. Now, for these points, those are going to be the new intervals that I have. So if I start off with my parent graph, which is cosine, so your parent t values, we remember we start at 0. So 0, we said pi over 2, and then we get pi, 3 pi over 2, and 2 pi are for the parent graph. Now we changed those values, so those values aren't going by those intervals anymore. Since it's a horizontal compression by 1/3, so I'm going to do I'm going to do 1/3, yeah, times all those values that I have from my parent t. So this is another way you can get your key points. So 0 times 1/3 is 0. And then if I do pi over 2 times 1/3, notice I get pi over 6. If I do 1/3 times pi, I get pi over 3. 1/3 times 3 pi over 2 gives me pi over 2, and 1/3 times 2 pi gives me 2 pi over 3. Now, when you're doing that, your new points should always be equal to one of your new wavelengths. So from 0 to 2 pi over 3 is my first wave for this new graph. That should always happen. Now down here, we're just going to actually do the cosine of 3t. And I'm going to use, of course, these values up here when I'm doing that. So the cosine of 3t, so we're going to start with 0. 0 times 3 is 0. The cosine of 0 is 1. Then the next one, pi over 6. If I plug pi over 6 in here, I would get the cosine of 3 times pi over 6. So 3 times pi over 6 is really the cosine of pi over 2, and we know the cosine of pi over 2 is equal to 0. If I do pi over 3, I would get the cosine of 3 times pi over 3, which is equal to the cosine of pi, which gives me a value of -1. And that's why I did 1/3 times those t-values, and I could keep going. If I did the cosine of 3 times pi over 2, notice I have really the cosine of 3 pi over 2, and the cosine of 3 pi over 2 is equal to 0. And then if I did 2 pi over 3 into the equation, I would end up with the cosine of 2 pi, and the cosine of 2 pi is 1. So those help me get all of those new values that I have. So that makes sense that when I start my graph, I'm going to use this as a value of 1, and I'm going to use this one as -1, so we don't write on all those numbers there. So we have 1, 0, -1, 0, 1. And then I could keep going with my graph. This would be the second wave. And then the next one would be the third wave. So from here to here is the first cycle. And then from here to here is the second cycle. And from here to here is the third cycle. So that's why it was a horizontal compression by 3, or by a third, because our graph makes 3 complete cycles from 0 to 2 pi, so it's a third of our original parent graph function for the cosine. So I'm going to write that in. So notice there are 3 cycles from 0 to 2 pi. And let's do one more graph. This will be our last one for right now. So let's do y equals 2 times the sine of 2/3 t. So for this one, my amplitude is 2. My b value is 2/3, so that means it's a horizontal stretch by a factor of 1 over 2/3, so 3/2. And my period then is 2 pi over your b value, so 2 pi divided by 2/3 is the same thing as 2 pi times 3 over 2, which gives me 3 pi. So 3 pi, and that means that my key points are going to be 3 pi over 4. And so if I want to make my table, I start with my parent t-values. So my parent t-values, of course, for sine start at 0, pi over 2, then we have pi, 3 pi over 2, and 2 pi. So then for I use my horizontal stretch, so I'm going to do the opposite of what I would do. So 3/2 times t are going to give me my new values. So 3/2 times 0 is 0. 3/2 times pi over 2 is going to give me 3 pi over 4. Because again, so you have 3/2 times pi over 2 is 3 pi over 4. And then for the next one, I would do 3/2 times pi, which gives me 3 pi over 2. And then this would be 9 pi over 4. And this one's going to be 3 pi. So if I do the sine, 2 times the sine. So 2 times the sine of 2/3 t. So the reason, again, we do the 3/2 times the t is because now we're going to undo it with the 2/3 times the t. So 0 times 2/3 is 0. The sign of 0 is 1, and 1 times 2 is 2. If I plug 3/4 in for t, 2/3 times 3/4 gives me pi over 2. The sign of pi over 2 is 1, and 1 time, oh sorry, this should have been 0. The sign of 0, 0 times 2 is 0. This would be 2. And then if I plug in 3 pi over 2, 3 pi over 2 times 2/3 gives me pi, and the sign of pi is equal to 0. So 0 times 2 is 0. If I plug in 9 pi over 4, 9 pi over 4 times 2/3 gives me 3 pi over 2. So 3 pi over 2 times 2 gives me, or the sign of that gives me negative 1. So negative 1 times 2 is negative 2, and then this one would be 0. So on my graph, I can just even count. So we're just going to do the first cycle, so I'm going to skip ones. So the first one is 3 pi over 4. So then to get the next interval, so we have 3 pi over 4 plus another 3 pi over 4, which gives me 6 pi over 4, which reduces into, which reduces into 3 pi over 2. That's where that value next comes in. So that's where 3 pi over 2. And then if I add another 3 pi over 4 to this, I get 9 pi over 4. And then if I add another 3 pi to this, I would get 3 pi. And if I add another pi to that, I would get 15 pi over 4. So we have 1 and negative 1 here, and then I'm going to graph. So sine starts at 0, 1, oops, and I guess I forgot we have an amplitude of 2, so I should go up to here, 2 and negative 2. So 0, 2, 0, negative 2, 0. And this would be my new graph.